right, everybody, it's Michael Shermer. It's time for another episode of The Michael Shermer Show, brought to you as always by Skeptic Society and Skeptic Magazine. Hey, here's the new issue on animal minds. Can they think? Well, of course they can think. But what are they thinking? Well, you have to read our issue to find out. You can go to skeptic.com/magazine to order your latest issue, order a subscription 1, 2, or 3 years, and order any of the back issues all the way back to 1992. Yes, we've been in business for a long time. There's a lot of bunk to be debunked. So, but we don't just do that. We also do a lot of interesting scientific questions. So my guest today is Kelsey Johnson. She's a professor of astronomy at the University of Virginia, former president of the American Astronomical Society, and founder of the award-winning Dark Skies, Bright Kids program. She's won numerous awards for her research, teaching, and promotion of science literacy. She lives in rural Virginia with her family, including 2 very big dogs. I bet they're not as big as my dog. I have a huge chocolate lab. He's 125 pounds.
Okay, mine is 120, so I think that
you're close. Well, mine should be 120, but he's overweight because I give him people food. Anyway, but her new book, here it is, Into the Unknown, The Quest to Understand the Mysteries of the Cosmos. And when I say that, I mean the biggest ones of all, like why is there something rather than nothing? What is the Big Bang? What banged the Big Bang? And all that great stuff. Dark matter, dark energy, multidimensionals, the multiverse, all that cool stuff. But anyway, before we get into that, Kelsey, nice to come on the show. Thanks for talking to me.
Yeah, so fun to be here.
So what's your story? How did you get into all this? When you were a teenager, did you watch Cosmos or something, or read Carl Sagan, or I don't know? What's everybody has an origin story. What's yours?
Oh my gosh, it's true. Everyone has an origin story. You know, my origin story is maybe a little bit weird. So are you ready to go on a tiny bit of a journey?
Oh, yeah, sure. Yeah. I love adventures.
Okay, so I grew up with a single parent. And my mom, she worked 3 jobs. She worked very, very hard. And we were very, very poor, like super poor, like we didn't always have electricity. We didn't always have running water. We didn't always have a phone, right? That kind of a poor,
Wow.
right? And gosh, I didn't intend to start the conversation out this way. My mom worked, I want to be clear, my mom worked very hard. She did her very best, but she had a very hard life and I think turned to alcohol because of that. So for me, I looked for a number of different escape mechanisms and survival techniques, and a couple have bearing, I think, on my origin. One is that I spent as much time outside as I possibly could, right? I just needed to be away and off on my own. And fortunately, we lived in a rural environment. And so pretty much every night that I could, and this was Minnesota. So I want to be clear, it got cold there sometimes, right? But every time that I could, I was outside at night. I even had a tent I would pitch outside and sleep out there in the summer. And I got very acquainted with the night sky and was sort of had it in my face every day in a way that I wish people did now, right? And I think when you see the night sky every day, it's hard not to start thinking about the really big, existential, beautiful questions that humanity has been thinking about for ages and ages. Then the other way this manifests itself is that for whatever reason, from an early age, I knew I needed to find a path out of sort of the trajectory I was on. And early in my life, the only form of a path that I could even see was religion. And we only had a few books in our house, but we had like 3 different versions of the Bible, and I read all of them multiple times. And I was sure that was going to, if I prayed hard enough, if I believed hard enough, if I was a good enough person, I would find my way out of the situation I was in. And that sort of became a seed for me, really wanting to understand my place in the universe. One thing I should add to this is an important part of the story, and this is probably the most painful part for me to relay, but I guess we're keeping it real right out of the gate. One of the things my mom told me often when she was intoxicated was that she'd wish she'd had an abortion.
Oh, God.
And so, so for me, early on, I became sort of preoccupied with why I existed and what my place in the universe was in a way that maybe as a child wasn't super healthy, but ultimately I think sent me down this trajectory, right? And so in hindsight, I certainly don't want to advocate for any children being abused or misused in any way. But in hindsight, I think if I had grown up in a normal, functional, nuclear family in suburbia, I probably would not have taken the path that I did. So that was a long answer, but you invited the journey and I went there with you.
Thank you for doing that. That's an incredible story. I actually think all stories are like that in a way, very contingent, very chancy. This happened, then that happened. None of it's plotted out. There was no reason, no grander reason. It just stuff happens. And, even if you had the perfect childhood or whatever, and you ended up being a doctor or something, that would still be its own contingent pathway. And it just happened to work out the way it did for you.
Don't you think that's crazy sometimes, though? I think a lot about these random things that happen to us in our lives. And if that one thing, that one tiny thing had been different, the entire path of your life would have unfolded differently. And I imagine you have a stockpile of these for yourself.
Everybody does. Yeah. I mean, if you ask, how did you get into doing Skeptic magazine now for 30 plus years? Well, I was in graduate school, and then I couldn't get a teaching job. It's 1979. And Prop 9, I think it was, passed and cut all the property tax in California. I just wanted to be a community college professor. So I couldn't get a job. I went over to the office at Cal State Fullerton for employment. And they go, well, what do you do? What are your skills? I go, nothing. I'm a college graduate. But, I like to write. And they go, well, all right, let's see what editing, writing jobs there are. And there was one at a bike magazine. So I ended up getting this job at a bicycle magazine. Then I took up bike racing, and I did that for 10 years. I was a professional bike racer for 10 years and ran the race across America and did all this crazy stuff. And then I, realized, well, I'm not going to be able to, race bikes for that long into my 30s. I better use my brain. So I went back and got a PhD in the history of science because I want to get a real college professor, not just a community college, so that I have more job opportunity. Anyway, then a history of science, one thing after another. I met Carl Sagan, Stephen Jay Gould, writing books, skeptics, and it was like, boom. So if you ask me, what should I do to become a skeptic? It's like, well, all right, you got to be a bike racer first. Like, I mean, what? I mean, this is, but they're all like that. I really think one of the limitations of the social sciences is predicting outcomes. You can do so statistically on large sample sizes, like people from this kind of neighborhood at this socioeconomic class who have single moms and, they're in public schools. You can kind of average all those out and say, 40% of them versus 80% in a affluent community will go on to college or whatever it is. It will have this average income in their life earnings, whatever. But you can never point to like that guy right there. What is he going to do? And the answer is no one has any idea. Because, that person may take that adversity and go, you know what? I'm going to be the best person ever at my job. And then he does. LeBron James is the example of this. He had the worst childhood you could imagine. And then he's the greatest NBA player of all time. So you just never know.
Which I think is actually beautiful, right? I think it's wonderful. How sad would it be if we all had predictive power about our futures? I kind of love that we don't.
I would not want to know. I mean, I did the 23andMe thing, but I did tick the boxes for the 2 genetic proxies for Alzheimer's, and I didn't have them. But then when you read the fine print, you realize if you have both of the genetic proxies, it only increases your chances by like 2% or something. Like, oh, okay, that's not really very predictive. But yeah,
but you understand statistics.
I love that story also because I love going out under the night sky. Still, I do this. I have a big, massive 12-inch Meade reflecting telescope, and I got all the lenses. And this thing is so heavy, I had to buy a whole set of wheels for the thing because you can't lift it. And I wheel it out there, and I look at Jupiter and Saturn and all that stuff. I mean, I know it's not nearly as good as just go online and under the astronomy picture of the day. My view is nothing like that. But I'm looking at it, and the photons of light coming through the lens into my eyes from Andromeda. I know how to find Andromeda. Like, what is that, 2.5 million light years away? Right? So the photons of light left 2.5 million years ago when hominids were just like a Lucy, a little tiny 3-foot high Australopithecine on the plains of Africa. That's astonishing.
Yep, I agree with you. I don't think there's a substitute. I mean, yes, I love the gorgeous astronomy pictures just like anyone else out there, but there's no substitute for seeing the photons with your own eyes and knowing you're seeing the photons with your own eyes, which I think for some people gives a little bit of a sense of cognitive dissonance. I mean, I'm sure you've had this experience if you've had guests looking through your telescope with you. Hopefully you have guests who look through your
Oh, they
telescope
do.
and
They
they might
can't.
see
People that have
Saturn or
not done this,
Jupiter,
they cannot believe it.
right?
Yeah, they're just
How is
shocked.
there like surely there's a picture there on the end
Yeah,
of the
right.
telescope, and right? It's almost hard
Yeah.
to deprogram our brains to think we're seeing it for ourselves.
Yeah, yeah, totally. And I also like going to observatories like Mount Wilson Observatory above LA, Lick Observatory up by San Jose, the Palomar Observatory in San Diego. Those are kind of old, antiquated. But the dome
Mm,
is like being in a cathedral. I also like going to
yeah,
European cathedrals. There's a sense of awe and wonder
yeah.
and like, wow, you know.
Oh, that sense of awe and wonder. That's the good stuff right there. We could talk about that for this whole interview.
Yeah. So when I'm just a point of accuracy here, when I'm looking out, what's the farthest I can see? You can't see Andromeda with the naked eye, right? I'm imagining that when I know where to look.
You sort of can. If you have really good eyes and you are at a really dark location, you can sort of see a smudge of Andromeda there hanging. For listeners or viewers who may not have any idea what we're talking about, Andromeda is one of our sister sibling galaxies. I think of it. It's very much like the Milky Way in many ways. And it's relatively nearby. It's one of the closest galaxies. And if you're looking in the night sky, if you happen to know where the constellation Pegasus is a great constellation because it just looks like a big square in the sky and it's hard to not see a square. There are lots of constellations that are like you have to connect this star and that star, and there's this random shape. But no, Pegasus is just a big square and it's really easy to find. And Andromeda is sort of both the constellation and the galaxy sort of hang off the corner of Pegasus. And you can Michael, if you are in a really dark location and you have really good eyes, and you probably know that if you want to see really faint things with your eyes, when you have very low light levels, you actually need to avert your eyes a little bit to the side and look at it in your peripheral vision. And if you do that, you can see it.
And the reason for that is because the rods on the periphery of your retina are more sensitive to dim light photons coming in as opposed to the cones in the center of the retina, right?
Yep, that's right. The cones peak up in the center, and then the rods sort of peek up more to the outside, and the rods are much more sensitive. They're only sensitive to grayscale, but they're much more sensitive on the outside of your vision, which is one of the reasons why it's kind of heartbreaking, right? People see these gorgeous color astronomy images and they go to look through a telescope and they think they're going to see these gorgeous color astronomy images when they look through a telescope at these very low light levels. But at low light levels, your cones just don't do a whole lot of good. And so you're only
Yeah.
seeing with your rods. And so you're only going to see grayscale at low light levels. And those are on the outside of your retina.
The other amazing part of that story is how recent it was that we discovered that Andromeda was not in our galaxy as little, I don't
Right?
know, a solar system or something. That's only not even a century ago, right?
Isn't yeah, and there was a huge this was the great it was called the Great Nebula debate. And can you I think about this a lot when I teach, when I teach my classes in terms of things that are really so paradigm shifting that they're going to shatter your worldview. And I imagine that at the time when we were debating whether Andromeda, what it was, and whether it was something in our galaxy or whether there was universe outside of our galaxy, right? We didn't even know there was universe outside of our galaxy at this point, right? And so that debate about whether Andromeda was its own galaxy was hugely paradigm shifting. And it's hard for us now with our modern knowledge to put ourselves back in that position and trying to imagine what it would be like to discover there are other galaxies. Today, I think the closest we could come would be like discovering there are actually other universes, right? It's truly like, what?
Well, that's one of my arguments for the multiverse because I don't have any others because I'm not an astronomer. But just that in terms of the history of science, it's always a bigger picture. There's one more level that we go, and so I know
Mhm.
there's other reasons to think that there might be a multiverse, but that would be a good one. Like, well, because this is what we typically find. As time goes on, it's a lot bigger than we thought.
Yep. And I will say, just if I'm going to be I'm going to lean into my book right now. I do talk about that in my book.
Yeah, I know. Yeah. Yeah, yeah. All right, yeah, let's start there. What is knowledge? Justified true belief. Okay, what is that?
Mm.
How do we know any of this stuff? How do you know the earth is round and then we actually went to the moon? No, just kidding.
Oh, I love this. And I know you really sit in the center of this and the work that you do. And what is knowledge, right? How do we know anything? Do we know anything? Like, know it with a capital K, right?
Mm-hmm.
Not the way we throw around knowledge sort of colloquially. And, if I'm being truly intellectually honest, and I know this is a controversial position, I'm not sure that we really do know anything with a capital K. And the reason I think that is that, when we think about epistemology, which is the study of knowledge, and we think about what it means to know something, um, it has to both, to know something, you have to both believe it and it has to be true. Well, how do we know if things are true? Well, that's where we need the justification. But how do we ever know for sure, like for sure, like 100% for sure that our justifications are watertight? And I think that that's where it's really easy for us to lead ourselves astray and thinking that our justifications are more watertight than they really are. Because even as contrived as an explanation might be, can't rule it out sometimes. And if we can't rule it out, that means that we have to maintain a little tiny sliver, right? A sliver. It doesn't have to be a big gaping wide area, but a sliver of understanding that we could be wrong. And I think there's some really important, rich, intellectual humility that comes with this that is uncomfortable for people to embrace sometimes.
Yeah, I like Bayesian reasoning and Cromwell's rule, based on Oliver Cromwell's famous quote, I beseech you in the bowels of Christ, think it possible you might be mistaken. Yeah, you never know. I mean, so just leave a little sliver of doubt just in case, but a lot of it is social, it seems to me, trust in the institutions. I talk about this a lot on the show, that, cognitive psychology studies of how people know things. And most of us don't know much of anything. So here I, quote the study by Andrew Stuhlman about, do his college students accept the theory of evolution? Yeah, they do. Okay, explain it. Oh, well, the giraffe stretches its neck and, no, that isn't it at all. So when they say they believe it, what they're really signaling is like, I trust those scientists. They mostly get it right. So, if they all say it's right. So now I don't know anything about quantum physics or astrophysics or whatever. So I trust you and the community of people like you that you're mostly probably getting it right. And then when I get these theories of everything, hey, I've been working on this on the weekends and, I think Einstein was wrong. You get these all the time, I'm sure.
Oh, yeah.
Now, how do I know that guy's not right? Well, did he publish in any journals? Well, come on, that's credentialing. Or did he does he have an EDU in his email? I know that seems kind of unfair to outsiders, but it's a filter, right? Like, you guys hard-earned this knowledge. For somebody to walk in and go, this is all wrong, they better have a really good argument.
Yeah, I completely agree with you. And I think about this a lot. Every time I get one of these emails with a theory of everything or overturning Einstein or whatever it might be, or sometimes actual paper mail shows up, which is like, they really put effort into that.
Right.
There's always part of me, usually if I'm being honest, right, it goes straight in the recycling bin or the delete folder in my email. But there is always part of me that wishes I had time, right? The problem is we don't have time, right? Because we get so many of these and so few of them, I think, are likely to be reputable that we don't have time to really give them any consideration at all. And maybe, have to open that sliver of possibility. Maybe one in every million of them is onto something, but we don't have time to sift through those other 999,999, right? It's just not feasible. And so we have to decide what we're going to put our trust in. And I think that's what you're talking about, right? We choose where we're going to put our trust. And one of the things I invite my students to do, and I think you invite your readers and your listeners to do, is really consider what you're putting your trust in and why you're putting your trust in those things. Because we as humans, let's be frank, we don't have time to go and learn all of the knowledge there is to learn. We have to trust other people to have learned things that then they tell us. But who do we trust and why do we trust them? So I do a fun exercise sometimes when I'm teaching, where I will have my students, when we're talking about epistemology, when we're talking about knowledge, and we're talking about what counts as justification, let's come up as a class with all of the different sources of information that we get, whether it's a parent, a teacher, a scientist, a religious leader, a friend, TV news of this kind, TV news of that kind, what social media, whatever it might be. Let's list all of those things. And then let's for ourselves say, how much do we trust them? And are any of them 100%? And if anyone ever says they're 100%, I push back. I'm like, are you really telling me that you don't think your parents have ever lied to you? Because I'm pretty sure that in the history of humanity, every parent has lied to every child that they've ever had, right? That's just part of parenthood. Now, so, and I like to push back on that. I don't mean to be antagonistic, but I want students to really consider the circumstances under which the sources that they trust could be letting them down.
Yeah.
So yes, trust, but maintain a little bit of skepticism in that trust.
But you guys, scientists, have earned the trust in the sense that it's a competitive enterprise.
Yeah.
You would be debunking each other if you could, because you could get status and grant money or whatever. So there's that, the kind of peer review system. And then there's a convergence of evidence, a consilience of induction, as philosophers call it. So how do we know the Big Bang is the right theory? Well, there's a convergence of evidence, from, I don't know, the microwave background radiation and the amount of hydrogen. I don't know. What are the arguments? And
yeah, I mean, you nailed it. Like the biggest, tightest argument comes from the cosmic microwave background. We can also talk about the abundance of elements. We can talk about the horizon problem, right? There are all kinds of different, we can talk about the expanding universe, right? All kinds of things that really lead to a convergence of evidence there. And that would be, it's going to take something really compelling to push that out of the way. But the thing with scientists that I think I want to say really explicitly, because I hear a lot from people, and I bet you hear this too, that scientists are like all in cahoots and they're all like in on something together and they're all hiding some great secret. And I guess people will have to choose whether or not to trust me when I say this. And I try to maintain as much intellectual humility as I can, because I think it's really important. But the thing with scientists, and I'm saying this to be just entirely candid, it's no fun. It's truly no fun to do an experiment and get the same result as someone else. We don't wake up like inspired to do that. What we wake up inspired to do is do an experiment and either A, find something that no one has found before, right? Because that's fun. Or B, like break a model that exists and find evidence that it's wrong for some reason. That's fun. So we're constantly trying to, not in a malicious way, it's just part of what we do as scientists. We are constantly trying to break things and debunk existing theories. It's just what we do. And so I think that's part of what gives the trust.
Like the steady state theory model that just lost out to the Big Bang because not enough evidence, one compiled more than the other.
Ooh, the steady state theory. I love this. Ooh, this is a fun time. Just to be clear, I wasn't around for this. This was before I was
the 40s
born.
and 50s?
Yeah, there was really a compiling of evidence from very different routes, right? So one of the first things that was already on people's minds in the mid 1900s was that thermodynamics had started to come into its own in the early 1900s. And the studies of thermodynamics were getting more and more sophisticated. And one of the things that thermodynamics tells us, you may be familiar with the second law of thermodynamics, which is entropy is always increasing. I'm abbreviating it a little bit, but we don't need to go into the details, which means that over time, everything runs down, right? That's just what happens. And so I think it was pretty clear to people by the middle of the 1900s that demonstrably looking around, the universe had not run down because we're here. And so there was a little bit of a rub there and people were trying to contrive solutions to it. And so that was sort of lurking off to the side. And then simultaneously, Edwin Hubble comes along using work from Vesto Slipher that came out of Lowell. And we start getting data on galaxies and we find these galaxies are all moving away from us. And so now we also find that the universe is actually expanding. And so if the universe is expanding as time goes forward, what happens if we reverse the clock and we look at what happens if time goes backward? And the natural conclusion to that was that we don't have a steady state universe. In fact, the universe is increasing in size with time, which means, if we take it to its conclusion, that there had to be a beginning. And so that is what set off a whole cascade of experiments and debates, and papers and discussions that has ended now today with an incredible preponderance of evidence that there was something like the Big Bang happened, and that we under no circumstances could we live in a steady state universe. And there's one sole exception here I just want to point out, because I don't know how often like young Earth creationists listen to your show, right? But if you were to talk to a young Earth creationist, they would argue, or they might argue, some of them have argued with me and probably with you, right? That no. The universe was actually created less than 10,000 years ago. And God put all of these things in place to make it look like it was created a long time ago, and make it look like there was something like a Big Bang, just to fake people out. Now, I think you know, and I know, and hopefully most of the listeners and the viewers know that that's actually not experimentally testable. So can't rule it out, but we also can't test it.
One of their arguments was tired light, right?
God.
The light is not really 2.5 million light years from Andromeda. The light just got tired, so it looks like it's further away.
Don't get me going.
You've heard this one, tired light?
I'm gonna be really good and not name any names right now, but I went to graduate school in astrophysics, right? With a student who was a young Earth creationist. And his whole purpose in going to graduate school was to get credentialed and get a PhD so that he could then go out into the world with his credentials and say outrageous things. He's very well spoken, super articulate, rhetorically brilliant, and also kind of lies through his teeth about things that he knows not to be true. For example, about his experience in grad school. And he has a book, and he talks about tired light. And I can't read this. And I bought the book because I wanted to know what his arguments are. And oof. Now my blood's going to start to boil.
That's okay. We like boiled blood. Why are people wrong? There was another guy in the 90s, I forget his name now, who he wasn't a creationist, but he was a skeptic of the Big Bang. And he wrote us, he wrote everybody to try to get attention. I forget what. But so your point is that if you have an alternative theory, say, to the Big Bang, your theory has to explain everything that the Big Bang theory explains and whatever it is you're claiming it doesn't explain.
That's right. Yeah, exactly. And that's real hard to do without getting real contrived and leaning really heavily on a God of the gaps fallacy.
Yes, right. Okay, so on the Big Bang, what banged? Where the stuff came from in the first place that banged? Or is this just, you just have to stop the questions at some point?
Oh, okay. All right, I have squirrels running around in my brain right now because there are a lot of different ways I want to come at this question.
Take a pick and go for it.
Take a pick. Well, the first thing I think I really need to clarify is what astronomers mean when we say Big Bang, because I think there are really deep and common misconceptions out there about the Big Bang that lead to misunderstandings in a way that is not helpful to furthering this discussion. So the first thing I want to say is that the Big Bang is a terrible name for what happened. I think when we say Big Bang, if I say Big Bang, the first thing that probably comes to most people's minds is some kind of like explosion, like a big explosion, and, somewhere in space. And I want to be really crystal clear that that is not what happened, or at least it's not what we think happened. And it got its name because a gentleman named Fred Hoyle was trying to make fun of it, and he called it this, and it stuck, and now we can't get rid of it. So this is why we can't have nice things, because people come up with bad names. What we do mean is that very, very early in our understanding of the universe's history, and by early, I mean like 10 to the negative 36 seconds, right? So that's a decimal point with 36 zeros and a 1, right? So really early times, the universe went from whatever size it had. It could have been a tiny little nugget. And that size increased by a factor of 10 to the power of 26, right? So that's a 1 with 26 zeros on the other side of it, right? So this huge change in size over an incredibly small period of time. And we call this cosmic inflation. This is what we mean when we say Big Bang. And I think people conflate the term Big Bang, this expansion of the fabric of space, with the creation of whatever that nugget was before expansion to begin with. And science can't speak to that right now. And the other thing I want to point out, just because I think it's really cool, is that the Big Bang, it didn't just happen somewhere else in the universe 13.7 billion years ago. It happened everywhere, right? All of space was part of this expansion. And so the Big Bang happened where you are sitting. I think you're out in California, where I'm sitting over here in Virginia, wherever the viewers or the listeners might be sitting and listening. It happened all of those places 13.7 billion years ago. So it was an event of space and not in space. And so I think that's an important clarification. But that only gets us back to whatever the universe was before that inflation. And then we get into the question of why we might have something instead of nothing.
Yeah. Yeah, just to be clear, the universe expanding is not expanding into anything. It's expanding its own time space of which it is a part of. There's nothing outside of the bubble that we know of, right? Well, I guess there's no way
that
to
we know of.
Yeah.
Right. This is the kicker. There's that we know of, because one of the first questions when I'm teaching about the Big Bang in class from students is, well, if it's expanding, what is it expanding into? And that totally makes logical sense. I absolutely understand why people want to jump to that there has to be an expanding into part. And that's not something that we can address right now scientifically. Yeah. It could be, right? It could be that there is something else out there, and there are multiverse theories that lean into that. But as of right now, we have no way to access dimensions outside of our 3 dimensions of space to really test whether there is something else out there.
Yeah. Then a technical question. Let's say here's our bubble universe. The 13.78, whatever it is, billion light years, that's the radius from the center to the edge. So it's actually double that or more because it's expanding at an accelerating rate.
I love this. Now, this is where I need a whiteboard. I'm going to go into full teacher mode on you.
Okay.
The 13.7, this is a really important number. We could round it up to 14 if we want to, just to be easy. But that is the entirety of time light has had to travel to us, right? So we can't see anything farther away than 13.7 billion light years away because light has not had time to get to us since the creation of the universe. That being said, there could be other parts of the universe that are farther away than 13.7 billion light years, but light hasn't gotten to us yet. So all we can say observationally, and this is where I like to lean into empirical inquiry as one of our important means of understanding the universe. All we can say is that the observable patch of the universe that we have access to started out really small, inflated by a factor of something like 10 to the 26, 10 to the power of 26 in a really quick time scale. There could be parts of, the universe outside of that, right, that are doing radically different things. We can't empirically test it. And so I think what I want to do is dispel the notion that we somehow know that we have a bubble universe that has a radius of 13.7 billion light years, because we don't. All we know is that we can only see 13.7 billion light years away.
I see. Right. And the expansion is accelerating, right? Another great revolution in science. And so it's even further away than that, right? It's bigger than, like, say, 28 billion light years.
Yep, that's right. And this is math that I don't know if I want to go into without a whiteboard, but right, because the universe is actually space itself is expanding, and that expansion is accelerating. The distances are actually larger than that now.
Yeah. Okay, so, but at the very least, like when a theist says, well, our universe had a beginning, and that's what the Bible says or whatever. Okay, leave the Bible out. But you would agree, yes, our universe had a beginning. A beginning.
Would I agree with that? This is where the rubber hits the road, isn't it? I am fairly agnostic on this because I don't know, because we can't observationally test anything beyond 13.7 billion years ago. And the laws of physics, as we understand them, right? We don't even understand what the laws of physics are or how they work before what we call the Planck time. So 10 to the power of roughly negative 43 seconds. I mean, that's really early. But whether there was a beginning, I think is a real open question. I know that, there are really popular hypotheses out there that time itself began with the Big Bang, and that could be true. And I hold that very much as an option that could be true in my brain and my own considerations. And if time itself began, then we really have a beginning. Like we have a beginning. And it doesn't even make sense to talk about what happened before the beginning because we don't have time. And so we can't use the word before. And so we get ourselves in kind of a linguistic knot because we don't have language to talk about things. But that being said, because we can't test it, right? For me, like this ability to empirically test things, I want to hold out I want to hold some openness for other possibilities that might be there because maybe one day we can test them.
Yeah, right. I mean, part of the problem, I think, Richard Dawkins makes a nice analogy of what he calls middle land. That is, we evolved in the plains of Africa where things were of a middling size, middling speed, things like the speed of light and quantum levels of structure and expanding bubble universes and all this stuff, multi-dimensions. There's nothing in our brain to hook it to. I mean, we're just
Exactly.
hunter-gatherers, right? And, snails move along and the mountain range doesn't move and lightning's pretty fast. But, that's pretty much it, that window. So, yeah, you have to use analogies. It's like this or it's like that, but it's not really exactly like that.
This is such a good point. And one of the things I tend to think about a lot as I hit the limits of my own intellectual ability, which I hit more often than I would like, right? And when I think we hit the limits of our intellectual ability as humans, is what our brains have evolved to do and what our brains maybe haven't evolved to do. And there may be people out there, I think this is probably the norm for people who don't think about it, who just kind of think that the human intellectual ability is like the pinnacle of what there is or what there might be, because we seem to be the pinnacle of what there is right now. But we know there are things that we didn't evolve to perceive that we could have, right? There are animals out there that can perceive different colors. There are animals that can perceive magnetic fields and polarizations and all kinds of things that our brains did not evolve to perceive, let alone think about. And so I think it's important for us to ask the question, are there things that exist that could be true that we have not evolved to interact with? And what might those be, and how might our worldview change if we could? A flip side of thinking about this is I also I think a lot about, all right, you and I have dogs, right? We know and love our dogs. Do you just have the one dog?
Yeah, just the one dog. Hitch.
Okay,
His
well,
name
I
is
have
Hitch.
two dogs that are over 100 pounds. So, all right, my dogs and your dogs are going to be friends. Um, I think a lot about my dogs, and I think my dogs are very smart as far as dogs go. Uh, but there is just no way I'm going to teach my dogs calculus. It's just not going to happen. I think it's not super far-fetched for me to assert that it is not possible to teach a dog calculus. I could be wrong, and if I am wrong, I would love to be proven wrong on this, right? This is one of those things that would be really cool. I don't think I could ever teach my dogs calculus. I don't think that their brains are wired in a way to remotely understand this. Now, let's extrapolate that a little bit, right? We know that our DNA is only like 1.2% different than that of chimps. Could we teach a chimp calculus? I don't know. Has anyone ever tried? I
I
have
don't
no
think
idea.
so.
I don't think so, but I'm kind of skeptical that would work. Now, what if our DNA were yet another 1.2% even more evolved in whatever way that means, right? I don't even really want to speculate what that means. And I'm not advocating for transhumanism. I want to be really crystal clear on that. Could we, by analogy, right, if you couldn't teach a chimp calculus, what can you not teach us now because we don't have the cognitive ability or the intellectual capacity to figure those things out? And so I want to hold space for that when we feel like we're hitting the limits of our intellectual ability as humans. And when I feel like I'm hitting the limit of my intellectual ability as my own self, I want to hold space for knowing and having the humility to accept that I am not pinnacle of intellectual evolution. And there are things that my brain surely cannot understand, no matter how kind and generous and patient a teacher might be.
Yeah, if we encountered extraterrestrial intelligences, surely they would have discovered the theory of evolution and Newtonian mechanics, although they'll call it something else. From
Hopefully they won't call it
from
after Newton.
Maslow's theorem, but they're not going to call it that.
Right.
But maybe,
Right.
if we present them like, look at this problem with dark energy, dark matter, they go, oh, we figured that out a million years ago. Here's what it is. Oh, I see.
Right.
In other words, it's a known unknown, but not a known unknowable, is what you're arguing.
Right. And I am arguing that. I'm also arguing that there are also unknown unknowns.
Yes, we don't even know what we don't know. Sure.
Right.
And I do wonder the question, why is there something rather than nothing? It may be one of these metaphysical questions that it depends what you mean by nothing. I mean, the word itself.
Yes, it does.
Yeah, no thing. So it's a thing that doesn't exist. Okay. But what about the concept itself? That if there was truly nothing, there would not even be the concept of nothing. And
exactly.
Forever, but there's no forever, because that itself is also a construct that would not exist. Yep. And at some point, I don't even know what I'm talking about.
I'm right there with you. I love these philosophical and linguistic knots that we get into because we don't have the language to talk about these things. And the concept of nothing, this is something that I suffer a lot of insomnia because I think about these things. And I tend to think about them when I'm trying to fall asleep and my brain is relaxing and putting together random thoughts. So I actually end up thinking about the concept of nothing a lot. And I've ended up teaching an entire unit on this in one of my courses.
Oh, wow.
Because I think when you framed it earlier as one of the greatest questions, right? One of the greatest existential questions is why we have something instead of nothing. And I'm right there with you. I agree with you. That's why it keeps me up at night. But I think part of the problem in having a rigorous conversation about this is a very imprecise definition of nothing. I think if we were to walk down the street and scare people half to death by asking them what they think of when they think of nothing, maybe that would be a fun experiment to do. I think most people would sort of think of something like an empty box with nothing in it. And that's a very generous interpretation of the word nothing. When I think about when I teach about nothing, I actually teach my students 3 different versions of nothing. And there are more versions out there. We could break them into smaller and larger categories. But I try to keep it small, right? Because I'm not trying to kill my students. I'm trying to just give them a framework to think about the concept of nothing. So the first type of nothing that I teach my students about, it's like the easiest type of nothing. It's a universe. We have a universe. There's just nothing in it. Right. So there's no mass, there's no energy, there are no force fields, right? It's just like an empty universe. And, one could question on theoretical physical grounds whether that's even possible, but let's just put a pin in that and put it aside for the moment. So it's just an empty universe. And by analogy, I really like to lean on analogies here because these concepts are so abstract, right? It's hard, I think, to get purchase. An analogy for me is, let's say you really want to buy a house, but you found a plot of land. And so there's a plot of land. The plot of land is empty and you're going to buy it and then you're going to put a house on it. But the plot of land is empty. So there's nothing on the land, right? But you have the land. So let's dial this nothing up a notch. So then there's a type 2 nothing. So a type 2 nothing is with this, let's say, real estate analogy. You don't even have the land, right? You want to buy a house. And so maybe you've gone and you've gotten permits, like you've gotten a permit for whatever you need. And there are regulations that exist on where you might buy a house or how you might build a house. And there are laws there, but you don't have a house and you don't have the land. Just these abstract concepts that might allow you to do things. So with the universe, I think about that as not only do we not have anything in the universe, we don't have any mass or energy or fields, we don't actually have the fabric of space-time itself, right? So now we don't have the arena in which for anything to happen. So this is a nothingness level dialed up a notch. And then there's more, right? Because we still have something. That permit you got to build the house is still something. So Now with the house analogy, you don't even have a permit. Not only do you not even have a permit, there's nowhere to get a permit. And there's not even a you to get the permit from, there's nowhere to get a permit, right? There's nothing. So there's no empty universe. There's no mass. There's no energy. There's no force fields. There's no space time. There's no dimensionality at all. And there's no underlying laws of physics or principles that govern anything that can happen, right? There's just no even abstract concept. And this digs down into, I like to call it sort of a philosopher's nothing, like a true nothing. But even as you indicated at the beginning, even calling it nothing is in contrast with there being a thing. And so we don't even really have a linguistic way to talk about this. So I think when we talk about us demonstrably now having something from nothing, we have to be really precise about the language we're using. And even to a theist, right, or someone who believes that a higher power of some kind created the universe, and I'm not here to disprove that because I can't and I won't, and I hold that possibility open in my own mind as not being empirically testable. But that higher power or that deity or that God that created the universe is still something, right? So we still haven't gotten to nothing.
Yeah.
And we end up in infinite regression and it's turtles all the way down. And so we really find ourselves in what I think is one of the greatest philosophical conundrums for humanity. And I don't see a way out of it. And this is one of those questions where I hit my intellectual limit and I think about it a lot. And I can't think my way out of it.
Yeah, the theist doesn't have a good answer either, because you could always ask one more question. Well, where did the God come from that created the stuff out of nothing? So apparently you can't, if God created the universe out of nothing, then apparently you can create something out of nothing. Well, but the God is that which does not need an explanation. It's not part of the natural world. Okay, then how does he reach into this universe to stir the particles to do whatever God does or create those in the first place? Maybe you're going to end up with something like, well, there's a quantum field with these, bubbling, what do you call them? The little, the bubbles out of which the universe is created, whatever that's called.
Yeah.
Maybe that's what God did. But then God is some sort of an architect or an engineer of super great advanced powers to be able to do that. And you're still in the natural world. This is my argument about the words supernatural and paranormal. These are just words. These are just linguistic placeholders we're using to explain things we can't explain with natural, normal means. In the same way, so we can say to this, that you guys use the words dark energy and dark matter. For you, that's not the end of the search. That's the beginning of the search. We're just calling it this for now until we can explain what's pushing the universe at an accelerating, what's holding these galaxies together, and so on.
Yep. I agree with you. And we need those words to use as labels so we can even talk about things.
Oh, but one more point on that, on the conceptual thing. So, I don't know, the sum of the angles equals 100, whatever, equals 180 degrees or
180, yeah.
Pi r squared. These geometrical principles, would they also disappear if there was nothing? I mean, these Platonic ideals, where are those located? And one more along those lines, when people like Max Tegmark talk about the universe as mathematical, what does that mean? The math principles are really out there somewhere, not just in the brains of sentient beings, but they're really out there.
Ooh, those are a couple great questions. Hopefully I'll remember the second by the time I answer the first. And if not, hopefully you'll remind me.
Well, you can say the laws of nature, where are they?
Yeah. So this is where we really start, I think, philosophically to finally define what we mean by different types of nothing. And for me, like the deepest, most underlying type of nothing is one in which even these mathematical principles don't exist, right? Because in some sense, right, and this is where I'm not going to define it because I don't think I can, in some sense, those abstract things like the Platonic ideals are things. They're not tangible things that you can touch or put on your shelf, but they're things, right? They're an underlying framework that allows things to happen. And I think the richest, best, deepest type of nothing, those even abstract concepts don't or can't exist. And this is where I think the rubber really hits the road with physics, right? Because when, I think the party line often in physics is that the universe came from nothing because of a quantum fluctuation.
That was it. Quantum fluctuation. Yes.
I'm simplifying it a little tiny bit. So hopefully people will forgive me. But for a quantum fluctuation to happen, right, there has to be an underlying arena principles governing laws of physics that enable that quantum fluctuation to happen. And so we're still not back to really what I would call nothing, like really nothing. But I will, to the second part of your question, I think I do tend to agree with Max Tegmark on this. My sense, having, spent many, many decades of my life among mathematicians and physicists, is that yes, we have human contrivances to describe mathematics, and we've created notation for equations and numerals and, the things we use to manipulate mathematics. Yes, those are from humans. But I think as close as I can come to a belief on many things, I do believe, right? Can I justify this? I don't know, but I do believe that math exists, right? That math is the language to say something that's often said. Math is the language with which the universe is written. And I do believe that we discover principles of math as opposed to inventing them. And one way, to me, this I actually have a little bit of a bet with my husband on this. We'll see if this happens. I have a bet that if this book that's coming out does sufficiently well, I'm going to get this tattoo. And that tattoo I'm going to get is Euler's equation. Do you know Euler's equation?
I don't remember what it is now. I've heard of it.
Oh my gosh, I need a whiteboard.
Yeah.
This is the most profound equation, I think. It's super simple, but it's one of the most profound equations in all of humanity. It's really easy. It's E, right? The letter E, to the power of I pi plus 1 equals 0.
Ooh,
That's
that
it.
is simple. Wow.
It's super simple, and it can fit on a tattoo, right? There are many equations I would not want tattooed, but I think this can fit in a tattoo. Okay, so why am I so jazzed about Euler's equation that I'm willing to get it tattooed on myself if the book does sufficiently well? Because this equation, this one super simple equation, incredibly economic, takes every single one of the most important numbers that we see in the natural world, E, I, pi, 1, and 0, and they are all related in a way. Why? Why are they all related in this one simple equation with no chaff, right? There's no like leftover random hanging on variables. And the fact that this equation exists to me is almost like a metaphysical epiphany, right? There's no reason why this equation should exist and work if math isn't just underlying everything. And so this equation to me is so profound that I am willing to get that ink on my skin.
Why do you have to wait for the book sales? Tattoos aren't that expensive. And where would you get it?
No. It's just more of a dare because
is this an ankle?
It would be. I'll have to think. I'll take suggestions.
There's a whole book
Maybe
about
not my
this.
neck.
I think it was Carl Zimmer's book of science tattoos. There's thousands of them. People get DNA on their arm or calf and equations and stuff like that. That's really cool. Yeah, Google it afterwards or just look under image.
I did have
science tattoos.
I did have a student once who had all of Maxwell's equations tattooed on their arms, and I thought that was real dedication. Yeah,
that is dedication. Yeah. Somebody has Darwin's tree from the first edition of the Origin of Species.
Nice.
Yeah, it's really cool.
Could we go back to nothing for a second though? Because there's something I really want to share with you. I don't know because I don't know if you know this. You might know this, but this is like a really, really cool fact about the universe. So we look at the observable universe that we can see, and we can add up all of what we see as mass energy, which is positive, and we can add up all of the potential gravitational energy, which is negative, and as near as we can tell, they cancel each other out. Why does this matter? This matters because in a real sense, as far as we can tell, the net worth of the universe is 0. In other words, it isn't like this really brings into question whether whether we have something that came from nothing, because what we have is a universe with a net worth of zero. And what does that mean? So the analogy I use often is, let's say you want to buy a car and you don't have any money. So you have a great friend and the friend lends you money to buy the car and you buy the car. So now you have the car, you have this positive value, but you still owe your friend the exact amount, which is a negative value. So you have a car and you have a friend, but your net worth is zero. And that's kind of where the universe is. And I think this is more profound than people, I think, normally realize, that the net worth of the universe appears to be zero. Now, the thing with the analogy is that your net worth monetarily is zero, but there is a real value in this abstract thing you have called friendship. And there's the fact that your friend exists and to be able to give you the loan to begin with. And this is where the analogy, thinking about how that works with the universe, becomes very interesting, right? So the question almost becomes not why do we have something instead of nothing, because we have the net worth of zero, but what was the mechanism for the loan, right? And how did that happen?
That's a nice analogy. And that's a different question from if the universe is flat. That is it going to expand forever? Is it going to collapse, or is it just going to hit a steady state at some point of expand? I don't know. That's a different question, right?
Yeah, that is a different question, but a really important question. And that's the question that led us to this discovery of dark energy.
Right. Okay. But one last thing. So maybe the question should not be why is there something rather than nothing. Maybe something is the natural state of things and nothing would be the weird thing that would need explaining. Maybe just things exist. That's it.
Right. Things exist. You just take it as a truism. And that is a philosophical position, certainly, that people have taken. I find that for me, I am not comfortable with that as a default. But there are certainly people who are.
Thomas Nagel calls that one thought too many, I think it was. I was talking about rationality, I think, or induction. Can you use induction to prove induction? Or, is there a rational argument for why rationality works? That's just, that's one question too many. It just does. It just works. That's it. It's a tool, something like that, maybe.
I think a lot about Tarski in conversations like this. I don't know if you're familiar with Alfred Tarski's work. He was a linguist, also kind of a mathematician. But one of the things he thought a lot about was whether within a language could define its own truth predicates. And the answer he came to was no. And in order to define truths and falsehoods within a language, you had to have a meta language outside of it to define the language. But then within that meta language, then you need it. So it's sort of like the inverse of turtles all the way down. It's like meta languages all the way up. But this was really stimulated in part by Turing's, Gödel's incompleteness theorem, right? So math was brought to its knees in the early 1900s when Gödel wrote out this incompleteness theorem, which told us, right, there are things that are true in the universe there are things that are true mathematically that cannot be proven within math. And it's pretty profound. And this is directly related to Tarski because you have to get outside of a system, whether it's linguistic or mathematical, or in this case, possibly our actual physical universe, to be able to define truths and falsehoods about that thing.
Yeah. Okay, so let's talk about the last esoteric question on infinity and eternity. So if these things are really true, that you and I are having this exact same conversation or something pretty damn close to it at some point, a trillion years from now or something, when all the atoms have to come back together. Some of this when I hear, I go, this just seems unlikely. It just doesn't pass the good smell test or whatever. I don't know. But I guess it's possible, right?
Yeah, I think we have to learn that sometimes our sense of smell is not as good as we would like to think that it is.
Yeah.
No, it is quite true. And this is something that has been worked out theoretically, right? Even if the universe isn't infinite in size or infinite in time, as long as it is sufficiently large, and it's actually quite large, statistically, somewhere, possibly far away in the universe, right? Things have played out from initial conditions in exactly the way they have played out in this corner of the universe. And it's a statistical certainty is the thing, right? It feels weird. It certainly smells weird. I am with you on that. It feels uncomfortable. I don't like to think that it's true, but I think you'll be the first to agree with me that just because I don't want something to be true doesn't mean that it's not. And me not wanting something to be true is a terrible justification.
Yeah, for sure. Okay, let's hit some of the other highlights of the book. The Fermi's paradox. Where is everybody? Where are the aliens? Assuming that the UFO people are not right and that, you know, they're not walking among us, or they're in Area 51, or the government's hiding them in some warehouse.
Right. Right. Yeah, this is I bet you get a lot of emails on this one too.
Yep, yeah,
Um,
but it's a fascinating topic. I mean, it's how could you
it's
not
a
be
great
interested?
topic. And it's right there in our face, right? And you know, as the story goes, Fermi was walking home from lunch one day and was like, "Where are they?" And then he gets a whole paradox named after him. Like, I'm
I know,
like, man, it
I know,
was easy to be a physicist back in the day.
I know.
Um, so I think, and I go through this in maybe too much detail in the book. I'll leave that for the
Oh no, I
reader
love that
to
stuff. Yeah,
decide. But the idea is with some pretty basic assumptions that I would argue are fairly well justified. One could infer that if extraterrestrial life exists, and if our assumptions are not totally crazy, it ought to have colonized the entire galaxy many, many, many times over by now. And I don't know that we want to go into all the details behind that argument now, because that would be a whole other. I think that would be a whole other show with you. Um, but there are reasons for believing that. All right, so if we take that as given for the sake of this argument, right, and we could push back on that, but let's take it as given for the sake of this argument that if extraterrestrial life exists and the assumptions that we have made are roughly true, and therefore it should have colonized the galaxy many, many, many times over by now, where the heck are they, right? And you know, conspiracy theories aside that you referenced, I don't see them, right? Where are they? I have never encountered one, and they ought to be everywhere. And so this is really where things get interesting, and I actually think serve as maybe a little bit of a warning or a wake up call for humanity when we think about our place in the universe. So I like to break solutions to Fermi's paradox down into sort of four broad categories. The first category, you know, where are they? The first way we might answer that is saying maybe our assumptions are totally wrong. It is much harder for life to form than we think it might be based on experiments and data and observations on Earth. And it just doesn't exist, right? Never has, never will. We are the only life that has ever existed in this galaxy, maybe in the whole universe. Kind of depressing, could be true. Can't rule that out. So that's category one. Category two is your conspiracy theories, right? They are here. We have seen them. We have interacted with them, but somehow, despite it being the most important thing that would have ever happened in humanity, we're managing to hide it. I find this pretty unlikely, but if I'm being intellectually honest, I can't totally disprove it. So fine, we'll keep that there as a possibility, even though I don't like it. The third category is uh, they they do they do exist, right? But we just haven't interacted with them, and that could have happened for a whole host of reasons. Maybe they haven't evolved to communicate. Maybe they have evolved, right? Statistically speaking, if life forms popped up regularly over the history of the galaxy, our next oldest siblings in terms of extraterrestrial life are probably like millions of years more advanced than we are. And if they're millions of years more advanced than we are, well, I don't think they're going to fly like a tin can spacecraft and crash it in the Southwest.
In New Mexico. Yeah,
In New
they're always
Mexico,
crashing.
exactly. And I know they're always crashing, right? And they're like probably a million years more advanced than we are. And B, if they're a million years more technologically advanced than we are, like think about how much technological advancement we've had in 100 years. We didn't even have we only had airplanes like 100 years ago, right? A million years more technologically advanced. If they don't want us to see them, I'm pretty sure we're not going to see them, right? I just kind of take that as given. So there are all kinds of ways we can think about that and unpack that part of it. But then there's the fourth category. And the fourth category for me is where things get real. And that is, sure, life is easy to form, probably has formed all kinds of times over the whole course of the galaxy, done all sorts of stuff, but they die. and they die fast. They probably die pretty soon after reaching their technological adolescence before they can get past it and go on to colonize the galaxy. And so they did exist, they have existed, but they all wipe themselves out. And for me, I wish that I could say I think that that possibility is unlikely, but I don't, right? When I look at humanity and the way we define being technologically advanced when we think about ET life has to do with being able to use radio communication and the different laws of physics that we have discovered. And yes, it's a very egocentric definition of intelligence, but it's what we've got to work with. We are, I would argue, we are very much in our technological adolescence right now. And the question is, like, we absolutely have the capability to destroy ourselves. The question is whether we have the wisdom not to. And so for me, all of society right now is kind of like, I actually have no idea if you have children, Michael. I have 3 kids, 2 of whom are young adults right now. And so I'm acutely familiar with this process. But for me, it's kind of like all of society doesn't have a fully developed prefrontal cortex,
Yes,
right? We are smart enough to do things like drive. We can even go buy alcohol. We could sign up for the military. But our brain is not fully developed, right? So we could do a lot of really stupid things too. And so for me, with Fermi's paradox, when I really think through the likelihoods of the possible answers or the possible resolutions to the paradox, I'm really left sitting with this heavy belief that maybe it's that once life reaches technological adolescence, it wipes itself out. And we better be careful, because I would like to humbly suggest to you and to everyone that maybe we not be one of those statistics.
That's a good idea. Let's keep surviving.
I'm all in favor of that. Yeah.
Yeah, I once calculated the value of L at about, I think it was 410 years, the lifetime of a civilization, because you need a civilization of some kind to fund a spacefaring program or a search or something like that. But that aside, I think another category is you can have the evolution of life, bacterial grade life all over the place, and that's not going to get you anywhere. But you could even get all the way up to something like Neanderthals, who were not showing signs of progress toward, the kind of technology we have. And maybe we would have gone extinct and the Neanderthals survived, and they likely would not be having radio telescopes and spaceships and things like that. So short of an alien civilization coming here, they wouldn't know we were here unless they had.
Right.
Well, I guess they could discover us through those exoplanet searches where they look at the light going through our atmosphere and they say, well, there's cows there because there's methane in the atmosphere or something like that. Right. But yeah, my answer is something like yours. Although I guess I would. It seems to me maybe the colonization of the galaxy problem solves this, but it's mostly empty space. It's just the vast distances of nothingness, and maybe they just missed us. Or maybe the timing. It could lasted millions of years, but then that was millions of years ago, and they're gone.
Yeah, it could be. There are arguments against that, but we have to hold open the possibility that that could be true. I mean, yes, space is really big, and the size, the sheer distances between stars that might be habitable is enormous, right? If the sun were the size of a grapefruit, right? Hopefully everyone can envision a grapefruit. The nearest star to us, which would be the size of another grapefruit, would be basically the distance between me and Virginia and you in California, right? That's a lot of distance between grapefruits, for sure. But there are also reasons to think that maybe with time and technological development, that distance isn't so great. We are on the verge of cryptobiotic preservation, right? People are already signing up and paying lots of money to do it. In just 100 years, roughly, we started from not even having airplanes to now having spacecraft that travel at, appreciable, really quite appreciable speeds. And so I think there are, with even 100 more years of technological advancement for us, I don't think it's crazy that we might be embarking on populating other solar systems. I'm not saying we should, right? Whether we can and we should are very different questions. There's a lot of ethics to think about in here that I think people tend to sweep under the rug, but we could. And there are lots of reasons we might when we think about the history of human migration around the world and overcrowding, famine, persecution, war, whatever it might be, right? There are reasons why people migrate and at great risk, right? And at peril, with a great degree of peril and often loss of life. But they make these journeys, and we've done it over and over again in humanity. So
Yeah.
I don't know.
And then the other counter is that these might not be alien beings, but just robotic spacecraft. And you make them self-replicating, and you have trillions of them. They would colonize every single solar system and every planet.
That's really a pleasant thought.
That just seems like, okay. But I guess if you have 100 million years, yeah, that's a long time.
It's a long time. And look at what AI is doing now. Maybe we should ask ChatGPT to do this for us.
No, have Elon do it.
oh, good God. Let's not open that can of worms.
Yeah. Okay. So the block universe, this also interests me, because if there is a block universe, everything's already happened. And we're just in this one little slice. Think of a loaf of bread, I guess, with slices in there. And if that's the case, then there cannot be any free will, right? Because everything that's happened has already happened, and we just don't know what it is, right? But is there any evidence that we live in a block universe and everything's already determined? Or what are your thoughts on that?
Is there any evidence? Okay, the short answer is no. But yeah, so here's the thing. We are now getting into the nature of time.
Yeah.
And I love that we're hopping from, robots taking over the galaxy to the nature of time. I mean, what else? I've got my coffee. Maybe I should have bourbon.
Go for it. Keep going. Let's go.
I'm not allowed to have bourbon on university grounds.
Oh, okay.
Sadly. So, okay. Upshot, TLDR for people who don't want to pay attention, right? We do not understand the nature of time, like full stop. And, not too long ago, only a century ago, I would say the nature of time was 100% in the realm of philosophy. But, quantum mechanics and general relativity in particular have started giving us insight into the nature of time. And they both have implications for what time might be and what time might not be. And one of the things that I think physics has come to the conclusion of is that time is not just some abstract concept that exists only for us to be able to assign durations to things. Instead, what general relativity suggests is that time is an actual dimension, right? It's an actual part of this fabric of space time, and it's not just abstract. So it exists in and of itself in a way that I think is not comfortable, I think, for a lot of people to think about, because we don't interact with time in this way. For some reason, and this is one of the big mysteries in physics, time as a dimension has manifested differently than the three dimensions of space. That is a big question. Okay, but we think of time, it's an actual thing, and it is a thing that can be manipulated, and in some ways is manipulated everywhere all the time. It is manipulated by gravity. It is manipulated by the speeds at which things travel, and who knows, maybe it's manipulated by other things too. So we're getting more insight into time. One of the pieces of this is that it could be, right, that time itself isn't just purely continuous, that it actually is made up of little bite-sized slices of time. Like, think about like an old movie reel. I don't know, maybe, I don't even know if listeners are familiar with old movie reels anymore, where you have little frames, right? And each frame is a section of time, and they flash by fast enough that they appear to be continuous to our senses and our perception. Time could be like that. And one of the things that quantum mechanics suggests, because below a certain time scale, this, again, the Planck time, 10 to the roughly minus 43 seconds, it isn't even clear that time is defined as a thing, right? It becomes very amorphous and very hard to get your hands around. So it could be that time actually unfolds one frame at a time, and those frames may be something like 10 to the minus 43 seconds. And so this is called the block universe, where it's sort of built up frame by frame by frame. And then the other piece of this you alluded to, and this is where relativity takes us, is that my now and your now are not the same now. And that's just a fact. And what that leads us then, if my now and your now are not the same now, that means that my past and your past are not the same past, and my future and your future are not the same future. And in some real sense, that means the past still exists, right? And the future might already exist. But then, of course, hopefully everyone is like, well, okay, all right, maybe I'm with you there. But why do we find ourselves in our consciousness in this particular now, right? And not some now in the past or some now in the future. And I don't have an answer for you. But these are where some of these are the hypotheses that some of modern physics is leading us to. And it could be, if the future exists, please be mindful, I'm using the word if, right? If the future already exists in some real sense, that would be a problem for free will. Now, quantum mechanics, as always, like, comes in from left field and tries to save the day, because one of the things quantum mechanics could do and might allow to happen is that as the future unfolds, sort of one step at a time, every time you make a decision about anything, right, that alternate universe like spins off. And so one interpretation of quantum mechanics, the Copenhagen interpretation, I think is often the most popular in physics, but there are other interpretations. And one of the other interpretations I'm sure you're familiar with is the many worlds hypothesis. And that is that when things happen, right, and quantum mechanical wave functions or decisions you make have to decide on a path or on a value, they don't decide on one. They pick every single one. And every single one of those paths or those values becomes manifest in its own version of the universe. And so in that case, if that is the correct interpretation of quantum mechanics, again, please note the word if, right? If that is the correct interpretation of quantum mechanics, what that means is that there might be some version of free will allowed in terms of which of those trajectories you or your consciousness finds itself on, right? But free will, this is the good stuff. This is where physics is actually starting to have some purchase on things that were once only philosophical. And I think this is super cool.
Yeah. Yeah. Well, I think of Heraclitus's line, you can't step into the same river twice. The river's not the same and you're not the same. But that assumes entropy, right? In the second law, that things are running or changing from moment to moment to moment. But I guess what you're arguing, that if it was a block universe, those particular moments have already happened in some other outside of the universe or something. It's just so wild. It's just, I don't know what to make of that. But in terms of my own perceptions, I don't know what already happened. So I'm choosing on some level, because I've learned from my past. The last time I stepped in the river, this is what happened. So I'm going to step into it differently this time. Something like that. I don't know. Yeah, that's one of those.
Inquiry for the win.
Yeah, yeah, that's a hard one. Okay, and then related to that, I guess, would be, why are the laws of nature and the universe structured the way it is? The fine-tuning problem. Of course, theists love this one. And they'll quote people like, who's the royal astronomer, the just six numbers.
Martin Rees?
Martin Rees is just six numbers, yeah. It's like, yeah, okay, those are peculiar numbers. It looks like somebody was, tuning the knobs at the beginning from the outside, whatever. You know the argument. So what are the explanations for why the universe is tuned the way it is, if that's even the right word?
Yeah. I don't, I'm glad you phrased it that way, because I do wonder whether it's the right word, because that implies there is tuning to be done. Right. And it does appear to be, right, as you've just summarized, that there are a lot of things baked into our universe that, had they been ever so slightly different, right, things would have turned out very, very differently, and we would not be here. That's fine, right? I'm totally willing to accept that. Where things get interesting is when you start to consider explanations for why that might be. Now, first and foremost, we've got to put front and center the anthropic principle, right? And this is the idea that I know you're familiar with, that of course we find ourselves in a universe that allows for us to exist, because if the universe didn't allow for us to exist, we wouldn't be here asking this question. And so I think we have to keep that front and center, but it only kicks the can down the road in some ways, right? It still doesn't explain why we have the universe with the values it does, only that we are allowed to be here. So there are lots of explanations for this. Of course, there are theological explanations, and I don't want to necessarily discount those because we can't test them. But there are other hypotheses too, and I think it's important that we keep these in mind and we think about their pros and cons. So, for example, you mentioned earlier the the multiverse possibility, right? If there are many universes, possibly an infinite number of other universes, and they all have their own different values baked into them. Some of them will allow for life like us, some of them won't. But of course, we're going to find ourselves in one that allows for life like us. So, let's hold that option open. And there are real reasons to think that there might be multiverses. But again, not currently testable. And I want to be intellectually honest about that. Uh, there are other explanations, though, too. So, for example, one of my favorite explanations is we talk a lot about life as we know it. That's great. We have life as we know it here on Earth. But maybe we're being pretty myopic about what we consider for life and the kind of life that could emerge in different scenarios. And I would argue, and I think you'd probably be right there with me, that our definition of life is pretty crummy.
Mhm.
And we tend to be pretty provincial in how we think about it. But what if we think about it with much more creativity and imagination? Could we imagine forms of life that could evolve under radically different physical conditions, and what they might think, what they might be like? And they were going to find themselves in a universe quite different from ours, possibly asking the same question, right? Why did they have these parameters and values baked into their universe that allow for them to exist? And they might think our existence is outrageous. Like, how could you possibly have life under those conditions, right? They might be very dismissive. And it could also be, so there are a whole host of possibilities, and I don't know that we want to go down them one at a time, but I do want to bring one up that I think is really one final one up that I think is really important. And that is, we don't know why the values have the values that they do. And this really bugs us, I will tell you, as physicists, right? I think a lot of people who are taking an introductory physics course or encounter any of this, like open their physics. People don't have actual textbooks anymore. Never mind that. But they're doing their homework and they have to use a physical constant for something. Maybe it's, the speed of light or the mass of an electron, whatever it is. They have to use it and they plug it into an equation. They don't really think about it, right? It's just a constant that you look up and you put in. I don't know if people really understand how much it annoys us as physicists that we don't understand why these things have the values that they do. Right? It's one of these huge questions just sitting there in plain sight. Like, why that value and not some other value? Why is the speed of light exactly that, right? And when we don't have an answer to that why, that keeps us wanting to dig. So here's the thing. We don't know why these numbers have the values that they do, but we also don't know what range of values they could have possibly had, right? So let's take the speed of light, right? 3 times 10 to the 8 meters per second. Maybe it had to have that precise value for some reasons we don't understand. I don't know. Maybe it could have been between 2.9 and 3.1 because there's some other bounding conditions that require that to happen. We don't know. Or maybe it could have had a value between 1 and 100 gazillion. So the range, how finely things are tuned, is making assumptions about how much tuning is possible, right? Does it just go from 0 to 10? Or if I was going to make a Spinal Tap reference, does it go all the way up to 11, right? Like what? And so it may be things are tuned a little, but maybe it's really not that fine. Or it may be things are tuned a whole lot. And until we are able to constrain what the range of values could have been, it's very hard for us to make an argument about that.
Yeah. Nice. And would it the argument or the whole field change if you had a unified field theory that what is it, unified quantum physics and general relativity, something like that? And then it could be like, oh, I see. Now it makes sense that it's this way instead of that way or whatever.
Yeah. Yeah. If we could unify quantum mechanics and general relativity, we would make a lot of headway here. And let me, if I can, let me tell you why.
Yeah.
And this gets into one of the leading theories for unifying general relativity and quantum mechanics. And I want to pull this out for people who are watching or listening, right? We have these two major pillars of modern physics, right? We've had them for about 100 years, give or take. And each of them in their own right is weird, right? Super weird. But each of them in their own right has been tested and tested and tested and tested with harder and harder and crazier tests. And they keep passing all of their tests, right? So we have really incredibly good confidence in these two pillars of modern physics. But here's the rub. They don't get along, right? They are not compatible. And so something with one or both of them has to give, and we don't know what that is. And so this is why physicists are yearning for this unified theory that will enable us to combine general relativity and quantum mechanics. Okay, what does this have to do with fine tuning? Good question. I'm glad I asked it of myself.
Thank you.
Here's where it comes in. So one of the leading theories for explaining how we could unify general relativity and quantum mechanics is called string theory. I imagine folks have heard about string theory. And the way string theory works is that you have these, they're called compactified extra dimensions. And in these compactified extra dimensions, you have these vibrating strings of energy. And it is the vibration of these strings of energy that give physical constants or particle values or whatever it is, it gives them their precise value. It's exactly how the string vibrates in this multidimensional space that translates into a value that we observe in our world. Okay, one of these values that we might say has been fine-tuned. But it depends entirely on the geometry, the topology of this compactified space. The versions of these compactified spaces that are thrown around are called Calabi-Yau manifolds, and they're you may have seen sort of projections of them. They're these multi-dimensional spaces that are just beautiful.
Yeah.
But there are like a gazillion possible Calabi-Yau manifolds. And so it could be that when our universe inflated, right? We talked about the inflation period earlier in our conversation, right? The 3 dimensions of space and 1 of time inflated to be macroscopic, but for whatever reason, these compactified dimensions didn't inflate. And they didn't inflate and they have a certain topology. But it could be, right, that exactly how the Calabi-Yau manifold is shaped determines the values of these apparently fine-tuned properties. And it would explain it, right? If we could understand, well, if we could prove string theory, which we're not in danger of doing anytime soon, and we could demonstrate that Calabi-Yau manifolds exist, which maybe could happen in our children's lifetimes. There are things that we might be able to start doing with really next generation super colliders that could start to probe small dimensions. But we could, in theory, right, as we become more technologically advanced, start to investigate these Calabi-Yau manifolds if they exist and the possible range of topologies they could have. And if we could constrain the range of topologies they could have, then we could start to see what apparently fine-tuned constants come out of that. That was a very long explanation. So I'm going to pause now and
that's
let
good.
you get
That's
in there.
good stuff because it also transitions to your chapter on multi-dimensions, right?
Mm.
So once we're familiar with intuitively 3 dimensions plus time, how do you conceive of more than that? And I guess you have to use analogies or something.
You do have to use analogies. It's really fun. I wish maybe someone can find this for me. A long time ago, by which a long time I mean like a decade, so maybe not that long. I got to be in my bonnet about this because what I really wanted to know was whether humans, we talked about we evolved, to have the senses that we do and perceive the things that we do. Is it possible that given the right circumstances, humans could perceive extra dimensions if they existed? Because we have not evolved, even if extra dimensions exist, they don't appear to have an impact on our daily life. They don't appear to be necessary for survival. And we certainly don't appear to have the senses to interact with them. Is it possible humans could really perceive extra dimensions under the right circumstances. And so I found a paper a long time ago, and I have not been able to find it. And I really wanted to cite it in my book.
Hmm.
That it was a psychologist who was looking about this and doing research on it. And there were sort of three ideas. One was no, right? Our brains are just not hardwired to ever think about other dimensions in a way that is really intuitive, like full stop, like don't even bother. The other was maybe with a lot of training, right? A lot of training looking at sort of rotations and slices and orientations of extra dimensional objects, you could start to exercise parts of your brain and build up that sort of neurological circuitry, maybe. And then the third option was yes, but only if you start subjecting people to this, like basically immediately at birth, right? When they have these really plastic neurological connections. And we're getting into your field here, right?
Mm. What
And
about
the brain is
psychedelics?
exactly. And so you're actively like rewiring your brain and training your brain to do things that it goes on to do. And so I will confess, as a parent of three children, that I spent a lot of time in my children's early childhood showing them multidimensional objects and trying to help them build up intuition there. I don't know that it did anything.
You mean like a
But the point
hypercube?
is, yeah, like rotating hypercubes, rotating just all kinds of different multidimensional topics or objects. But you know, we're limited because we live in this three-dimensional world, right? What are we
Yeah.
going to do? It's not like I have multidimensional objects sweeping through my living room every day. Although that maybe that would be good. It might clean it on its way out. Um, so there's a real problem here, right? So there are physical reasons why we think extra dimensions could exist. Um, but the problem is, as far as we can tell, A, we can't perceive them. Okay, well, so what? Human perception kind of sucks, which is why we have all this fantastic laboratory equipment to probe things that our own senses can't perceive. But it doesn't appear as though the forces that we interact with in the universe have any interaction with these extra dimensions either. Maybe. Gravity is the odd duck out here. Gravity is always the odd duck out. And it could be that gravity is telling us something about extra dimensionality. And so I think a lot of us are holding out some hope for that.
Amazing. This is all such good stuff. Can you imagine being chronically frozen and coming back like 1,000 years from now and you go, oh, I see. These guys have figured all this out. Like, you know, if you went back to Newton's time and told him everything you just told me, you'd be like, what?
Exactly. I know.
We
I
didn't know
know.
that.
Right. But that's the intellectual humility, right? Like I want to, and I want all of us to embrace this. We are not the pinnacle
Yeah.
of advancement and intellectual ability right now. So let's hold that door open.
All right, your last chapter. What's our place in the universe? Is that even the right question? What's the question? People want to know, you know, what's the purpose of my life or something like that. But you're asking something slightly different there, I think.
I am asking something slightly different there. And, you know, I added this when I originally started to map out the book, this chapter was not there.
Hmm.
And I decided to put it in. I think it was the very last thing I did for the book because really for two reasons. One, in the course of writing the book, I spent a lot of time thinking about why I was writing the book, right? Because you have to, because this is a big, you know, you've written lots of books. It is a big endeavor.
Mm-hmm.
And why am I doing this? And for me, at the end of the day, the reason I wrote the book is because I think it's really important that we try to incite curiosity that leads people to, um, you know, to questioning things, but also to awe, right? And to thinking about existential questions that maybe we shield ourselves from more than we should. And so for me, the last chapter of this book is kind of an overt invitation to people to dwell in this existential space and think about what it means to be human in this incredible universe that we have. And I know that many people I think just go about their, you know, go about your day-to-day life and the concerns and the worries of your day-to-day life. And I don't want to diminish those, right? Like getting food on the table for your family is important, right? Hitting that 5 p.m. deadline is important. I'm not saying they're not important, but I do feel like for the bulk of society today, we are increasingly losing touch with the universe, as we spend, more time on our screens, more time on our phones, less time outside, almost no time outside at night. Even if we do spend time outside at night, most people live in light polluted areas where they can't even see, more than like a handful of stars. And so I really worry that we are cutting ourselves off from the natural world in general and from the universe in particular. And I think that this is really bad. And I think it's bad for a host of reasons. And so I really want to invite people into a space of thinking about their place in the universe and opening up their worldview to there being more than the day to day, more than what you're going to make for dinner, more than the socks that you're going to put on in the morning. And I realize this is going to sound hyperbolic, and maybe it is, but this is authentically what I believe. I really believe that as we lose touch with the universe, we're losing that important avenue to experiencing awe. And as we lose that avenue to experiencing awe through these sort of existential questions that the universe invites us to ask, we are losing the curiosity, we are losing the creativity. We are inflating issues that are really in the cosmic scheme of things quite small. We're forgetting that we are part of something really beautiful and incredible, that we are part of, right? You've heard this before and you'll hear it from me again, right? We're literally fluctuations of the universe that are made sentient. And we might be the only ones. We don't know. We've got the Fermi paradox sitting right there. As far as we know, we are the only life in the universe capable of contemplating the universe itself. So for me, learning in general is one of the most important things humans can do, which makes teaching like the next most important things humans can do, which means creating the knowledge that can be taught like the third most important thing that humans can do. And I think all of that is being lost. And I really worry about as we lose touch with the universe. I fast forward 50 years or 100 years where no one anywhere on the planet can see a dark night sky, when all we have are hundreds of thousands of satellites whizzing around. You could be forgiven for even realizing that there is a universe out there. And if all of humanity is less curious, less creative, less thoughtful, less humble, what does that mean for us as a species? And I just don't think that ends well.
Yeah. Wow. Beautifully put. Kelsey Johnson. Here's the book, Into the Unknown, subtitled The Quest to Understand the Mysteries of the Cosmos. By the way, everything you just recommended is in Dacher Keltner's book called Awe.
Yep.
And he, this is exactly what he recommends. Do exactly what you just said. So get this book. If you want to get some awe, get this book and then go outside.
Amen.
Amen, brother. All right. That's a perfect place to stop. We hit the 137 mark. That was a great conversation. Really one of the best. Thank you so much.
Oh, what a pleasure, Michael. So fun to talk.
All right.